everybody, it's Tyler here at Riverbots High School, checking in 16610A Snacky Cakes, great name by the way. Winners at Lobster Bowl quite recently as well too, but they get a lot of great stuff. One of the things we got a lot of recommendations about this team was their mobile goal D score, so we'll be of course diving more into that. A lot of other great things from this robot too. Excellent design as they've gone all the way through. We talked about their clamp that they had, of course working with their intake and many other great features. So let's learn more about this team coming up here on Pits and Parts. Oh, let's round up on this robot here, a little bit about the drivetrain, then we'll be going more into your intake, so talk to me more about it.
For sure, yeah, let's start off with the drive base here. So we have a 450 RPM on 2.75-inch wheels. We have 6 motors driving it. This might be a little bit of a slow ratio compared to other bots, but we need to support the weight of all the features on our robot. So next we're gonna be going on to our intake design. So we have 3 stages of flex wheels, acting as kind of a hood section of our intake, and a top stage of a hook right here acting as the hook stage. So we like to say that we have a combination between a hood and a hook intake. So I'm just going to clamp this goal right here, and you can see that the ring will be spun up by these flex wheels and will reach the top hook stage and will be slammed into the mobile goal, just like that. So the reason we chose this design was because a common problem with the hook design was that they would have a long chain going through the robot, and it could like twist and it would snap basically. And if it snaps, then all their scoring opportunities, like they can't score anymore. So that's why we went with this design. We get the speed of a hood intake while getting the consistency of it and just the nice simplicity of a hook. So,
are there any design challenges when going with multiple stages though you might have to consider?
Definitely. A lot. We tuned compression a ton because we want it to be as efficient as possible. Having too much compression would mean that there would be more friction when the ring is going up, and it would be less efficient when trying to intake multiple rings at a time. So we try to get it as light as possible, trying just enough for it to push the ring up, but not compress it a ton.
Makes sense. So let's talk about the mobile goal clamp you got on the other side, and then we'll be talking a little bit more about the D-score in a little bit too. But Jay, talk to me more about the mobile goal clamp and the composition of it.
Yeah, so our mobile clamp is a little pretty unique from some other teams. You have these 225 mil pistons tucked underneath the robot to save a lot of space. We also have this unique polycarb design here. So when the pistons push against the top, it puts pressure on the mogo to efficiently clamp it. And this has worked really well in our competitions. And as you can see, these standoffs, they clamp onto the middle part. You can activate it. Yeah. And these screws help to support the mogo up and have it like the optimal distance from the hook.
Overall, great design for that as well too. We got to really talk about this D-score that you have as well. So James, on this, now this is something only for skills though, right James?
Yes.
So talk to me more about, like, first off, like, how did you come up with using this? Let's showcase, if possible, how it works, and then talk to me a little bit more about using it in skills.
Well, so right now, looking at the skills field, we can see that there's 2 mobile goal setup with blue rings on top. This prevents us from scoring on them because all red rings must be scored under blue rings. Now here we can see we have this D-score mech where we have this first stage of polycarb cutout that fits right under the goal. It will slide under the rings when we clamp onto the blue mobile goal, and here we'll bring it up to this stage where another piston will be kicking the ring out. Sometimes it doesn't work, which requires us to bang on the wall, but most of the times it will go straight out. And this allows us to unlock a skills cap of 74 points. We also have set up for normal tournament play, which is this polycarb cutout. As a lot of teams have it, this polycarb cutout usually fits right here for us to be able to line up to wall stakes a lot quicker. Now, it's not sacrificing much because this mechanism, it's really easy to take off, and even when we're not taking it off, we can just simply bend it back here, and it's completely match accessible.
And then from taking off this D-score mech, like how long does it take you to do that? Can you get it done in quick time, that sort of thing?
Well, we haven't had a lot of practice yet, so right now it's taking us about a minute to take it off. and about a minute and a half to put it back on.
I mean, that's not too bad, right? So
not too bad.
I was gonna say, I was gonna ask you to do it in real time. I don't think we'll need to do that, but cool to see that you're starting to hone that down. I mean, even if you haven't practiced that, I don't think a minute's that long.
Yeah, it's
for
not.
that too. Cool. So on this, by the way, last thing I just want to ask you from a skills-wise on there, is there anything else from skills maybe you're looking at doing? I mean, that's a pretty innovative thing. Is there anything else from skills you might have future plans on doing?
Well, future plans, maybe a tier 3 climb. That gives us a new skills cap. Maybe we would run this D-score and a tier 3 climb at the same time. I know a team from across the convention hall, Curity, they have a tier 3 climb. We really like their design. Apparently they're inspired by FRC Team 95, and it's a really cool design. It allows us to have a skills cap of now possibly the 86, I believe, and that's something we'll look into in the future.
So Stuart, on here, you got a lot of great sensors. First up, what's your reaction to hearing a tier 3 climb? Because usually they don't consult the programmers before they make claims like that. So, but run through some of the sensors on this robot you got.
So I'll talk about the sensors. So what makes our drive-based sensor unique is that we have this line tracker sensor, which most teams don't use. And what this does is we can use this during skills in Auton to line up our wall stake. So what this will do is it will look at the floor and it can tell between the floor tiles and the white line. So the robot will drive forward, and when it sees the white line, it will know that's in the middle of the field and knows that it can turn to score on the wall stake. And here we also have two rotation sensors that has 2 tracking wheels attached to them, and this allows us to use library lemlib, which is odometry, and it allows us to figure out where the robot is on the field and where it's facing, and we use that to plot our autonomous routes. And here, obviously, we use a inertial sensor to figure out where the robot is pointing at. And for color store, we have a color sensor in here and a distance sensor up here. So when the rings goes in, it'll go past the color sensor, and the robot will know which color it is. And when it reaches the distance sensor, we'll know when to stop the hook to eject the ring. And this helps a lot because it allows the driver to drive with a bit less care, knowing that the wrong color would not be scored.
Well, 16610A, thank you so much for taking the time to talk about it. Congratulations on your Lobster Bowl signature event win. I know you got high expectations also here at Riverbots, but can't wait to see how you do. A lot of great things that teams can learn from this. So congratulations on a great run, and good luck throughout the rest of the competition. Thanks a lot.
Thank you.